Respirable crystalline silica dust is generated during the dry cutting, grinding, milling, or drilling of granite or quartz surfaces products. The inhalation of respirable crystalline dust represents a significant potential health risk, a health risk that can lead to a number of chronic and potentially fatal diseases, such as bronchitis, silicosis, chronic obstructive pulmonary disease, collagen vascular diseases, and lung cancer. In general, the body has a number of mechanisms to trap and expel foreign particles such as dust. For example, non-respirable particles, particles larger than 10 microns in diameter, are trapped by the mucous membranes in the nose and throat and/or are chemically broken down and expelled by the body. These dust particles never reach the gas exchange regions of the lungs. Respirable silica dust is defined as dust that is hazardous when deposited in the gas exchange region of the lungs. Respirable dust is 10 microns in diameter or smaller and can reach the gas exchange region of the lungs unabated, clogging passageways with solid material, ultimately interfering with the gas exchange process. In the gas exchange region of the lungs, the body's ability to remove dust is greatly diminished. Consequently, the body isolates the dust by forming scar tissue around it. Excess scar tissue decreases lung capacity and makes breathing more difficult. This excess scar tissue buildup is called pulmonary fibrosis, and pulmonary fibrosis caused by respirable crystalline dust is called silicosis. Silicosis is a chronic lung disease caused by long-term exposure and is characterized by the formation of silica-containing nodules of scar tissue in the lungs. Simple silicosis, in which the nodules are less than 1 centimeter in diameter, as measured on chest X-ray films, is generally without symptoms, but can slowly progress, even in the absence of continued exposure. Complicated silicosis, where nodules are greater than 1 centimeter in diameter, is more often associated with disability and can also progress in the absence of continued exposure. Silicosis can be disabling, non-reversible, and sometimes produce fatal lung disease. Health effects can take as long as 20 to 45 years to manifest. In many instances, X-rays have not detected problems for as long as 15 to 20 years after chronic exposure. More than 1 million U.S. workers have been exposed to crystalline silica, and each year more than 250 die from silicosis. There is no cure for the disease, but it is highly preventable if employers, workers, and governmental health officials work to reduce exposures. There are several types of engineering controls available to reduce employee exposure to respirable crystalline silica dust during fabrication and installation of quartz-containing materials. One type of engineering control is to use wet fabrication techniques, where all cutting, grinding, and shaping is performed using water to trap the dust. In stone fabrication shops, much of the automated and manual equipment is already operated with water. Automated equipment includes bridge saws, linear edgers, CNCs, and water jets, while manual equipment includes grinders, grinders with coring bits, cutters, drill presses, hand routers and profilers, and polishers. However, there are some tasks that have traditionally been performed dry in the granite fabrication industry. These include dry cutting, dry grinding, dry honing, and dry sweeping. In order to minimize the amount of respirable crystalline silica dust in the air, dry cutting, grinding, and sweeping must be eliminated. This can be accomplished by purchasing tools that can be operated using water. By switching to pneumatic tools or electric tools that are designed for wet operation, respirable crystalline silica dust can be significantly reduced to acceptable safe levels or eliminated completely. In addition, dry sweeping and the use of air hoses to clean surfaces should be avoided when cleaning a shop floor or any shop surface. Dry brooms and air hoses should be replaced with wet brooms or garden hoses equipped with spray nozzles to clean shops. A second type of engineering control is the use of ventilation and filtration systems to selectively collect particles in the respirable range. High-efficiency particulate filters, or HEPA filters, are designed to collect respirable particles. When these types of engineering controls are implemented, it is imperative that the filters are replaced according to the manufacturer's prescribed schedule, and that equipment be inspected and maintained according to the manufacturer's specifications. Some shops have designed dust collection booths equipped with vacuum systems or waterfalls where operators can cut, grind, and shape product. These systems are very effective, but a few common sense rules apply. 1. The operator should always direct the dust plume into the water curtain or vacuum system. 2. The operator should work upwind of the cutting, grinding, or shaping operation. 3. The operator should work well within the confines of the dust booth. And 4. Any filters used with a vacuum system should be inspected and replaced as recommended by the manufacturer. While not an engineering control, respirators with HEPA filters may also be effective in minimizing exposure to respirable silica dust. Where industrial hygiene sampling indicates the potential for overexposure to dust not controlled by effective engineering controls, the employer must develop a comprehensive written program to establish respiratory protection for employees before supplying respirators. While respirators can be effective, there is a substantial cost and administrative burden to creating and maintaining a respirator program. Considering all of the alternatives to eliminate respirable crystalline silica dust exposure, including the protection afforded and the cost, the preferred order of containment would be 1. Wet processing, 2. Dust containment booths, including local dust exhaust ventilation, and 3. Respirators. The most effective way to minimize respirable silica dust generation in the field is not to produce any dust. This is accomplished by minimizing or eliminating field fabrication through the creation of accurate templates. When field fabrication cannot be avoided, any grinding, cutting, or shaping should be performed wet and/or performed outside. If fabrication outside is not possible, the HVAC ventilation system in the vicinity should be sealed off, and the fabrication should be performed wet or with local dust collection, such as a handheld vacuum fitted with a HEPA filter. In this video, we have shown many of the fabrication processes that can create respirable crystalline silica dust and have described the health concerns that are created by long-term exposure to this dust. In addition, we have described the various engineering controls that can be implemented by a shop to eliminate the production of respirable silica dust, a major step in creating a safe working environment for operators. As for the job site, we have described the processes that will enable installers of quartz-filled products to work with the product without creating respirable crystalline silica dust by using wet processes and working outside, or by capturing any dust that may be generated by using a local vacuum system with a HEPA filter. Lastly, while all of the recommendations provided in this video can be effective in eliminating exposure to respirable silica dust, the ultimate responsibility for worker safety must reside with the worker.